0 in exponent 0 equal with 1. In this case, I will bring just two arguments that support the idea 0 in exponent 0 is equal with 1. First of all, let me take the function. Let me take the function y x in exponent x. And let me take the limit here and to see does this have a limit at 0. And limit x approaches 0, x in exponent x. Since x in exponent x we can write in a different form. We can write in the form e ln in x exponent x. So I will write in this form because it's much easier to to evaluate the limit. And now let me write this limit in this form here. So limit x goes to 0, instead of x in x, I am going to substitute with e in ln x in exponent x. So e in ln x in exponent x. And now this one we can write in this form. We can write as a limit x in exponent approaches 0, e in exponent, so let me write with different color, x ln x. So I'm not using parentheses because it's much easier to go this way. And this we can write in this form e in a limit x approaches 0, x ln x, x times ln x. And now I can go a little bit further here. So this can be equal with e in exponent. So let me write this a little bit with different color. Limit x approaches 0. And this one we can write as ln x. And x I can write as 1 divided by 1 over x. And if we are substituting here, instead of the x 0, ln 0 is going to be infinity. And here 1 over 0 is infinity. So this form here is going to be indeterminate because it's going to be infinity divided by infinity. So, since this is indeterminate, we can use the L'Hopital rule. So we have a right to differentiate numerator and denominator. So I'm going to differentiate, and this here is going to take this form as follows. So let me write here what I'm doing. So I'm differentiating. Limit x goes to 0, and so I'm differentiating this part here ln x. And same thing I'm going to do down d over dx or 1 over x. If I'm differentiating here, this is going to get the following form. So derivative of ln x is, so just me write a limit, x goes to 0, and derivative of ln x is 1 over x. And here, when we differentiate 1 over x, is going to be minus 1 over x squared. And when we are rearranging, we are doing a little bit algebra here. This function is going to take the following form. It's going to take e limit x goes to 0, and everything here is minus x. And now if we are substituting with minus x here, if we are substituting x by 0, this is going to get this form, final form, e in exponent 0. E in exponent 0 is 1. So we already showed here. So limit x approaches 0 of the function x in x is equal with 1. This is the answer. We already showed. So we showed here 0 in exponent 0 is equal with 1. So this one supports the idea 0 in exponent 0 is equal with 1. And the other important idea is if we are going, for example, in a Desmos or any graphing calculator, and we graph the function x in x, and if we are substituting 0 here, 0 in a 0 is equal with 1. So this is the second argument that supports the idea 0 in exponent 0 is equal with 1. But is this enough arguments to support that? I don't know exactly. Maybe we needed to find more arguments. But those two arguments support the idea 0 in exponent 0 is equal with 1.